A nucleophile is an electron-rich species that donates electrons to an electrophile, often because it has lone pairs or pi bonds and seeks to form a new covalent bond. Think of a nucleophile like a kid with an extra Lego piece who wants to connect to another Lego that is missing a stud. The nucleophile has electrons it can share, such as lone pairs on oxygen or nitrogen or electrons in a double bond, and it uses those electrons to form a bond with an electron-poor atom called an electrophile. Nucleophiles can be negatively charged or neutral, and their strength depends on how available those electrons are, which is influenced by things like solvent, charge, and how tightly the electrons are held. A strong nucleophile readily donates electrons and reacts faster, while a weak nucleophile holds on to its electrons and reacts more slowly. Remember that size and polarizability matter too, because larger atoms can spread out electrons and sometimes attack more easily in certain situations. Students often think that every negatively charged species is always a strong nucleophile, but charge is just one factor, and solvent or steric hindrance can slow reactivity, so check the whole environment before deciding. If a nucleophile is bulky, it may struggle to reach the electrophile, so use a smaller or less hindered nucleophile instead. Another common mistake is confusing nucleophilicity with basicity and assuming they change in the same way, but they do not always correlate directly, so compare trends in the correct solvent and context rather than assuming both follow identical patterns. Some learners forget that neutral molecules like water or alcohols can act as nucleophiles too, so remember to consider lone pairs on neutral species as possible nucleophiles when predicting reactions. For more videos and resources that explain nucleophiles and reaction mechanisms, visit www.gumballdegree.com.